Understanding the relationship between amps, volts, and watts is essential to understanding electricity. Here's a brief explanation. Amps, or amperes, measure the volume of current, or in other words, the amount of electrons passing a given point every second. Volts measure the pressure or force under which electricity moves. Power companies supply homes with electricity under 120 or 240 volts of pressure. Finally, watts are what we use to measure electrical power. In a well-used example, to clarify these differences, let's compare electricity to water, where amps can be compared to water in a hose. Volts are the water pressure pushing the water through the hose. The total amount of water used is the watts. Volts, amps, and watts are directly related to one another. By multiplying volts and amps together, we can calculate the total power of the electrical current, or watts. By multiplying volts and amps together, we can calculate the total power of the electrical current, or watts. For example, 120 volts times 15 amps equals 1,800 watts. Where this knowledge comes in handy in a practical situation is this. Let's say you're putting together a plan to wire the lighting in your home. You should estimate how many total lights will be connected to that circuit. You simply add up the total amount of wattage you estimate your lighting will use to determine the total amount of power you will need on that circuit. For example, if 18 100-watt light bulbs were included on one circuit, it would take 1,800 watts of power to turn them all on at once. 1,800 watts of power is the total capacity of a 15-amp breaker. Always be safe and conservative when organizing your home circuits. Even though a breaker may have a rating of, say, 15 amps, it is unsafe to operate a circuit at its total capacity. You should never exceed what is known as the breaker's safe capacity. A circuit's safe capacity is 20% lower than its total capacity. This means that if a breaker has a rating of 15 amps and can sustain power of 1,800 total watts, the total amount of current passing through that circuit should never exceed the safe capacity of 1,440 watts. If you respect electricity and play it safe, you can avoid serious problems caused by the dangers of overloading a circuit.